Welcome to AI Frontiers, exploring the latest in artificial intelligence research. In this episode, we offer a deep dive into 29 newly published papers within the field of computer science artificial intelligence, dated December 30, 2025. Today's guided tour will traverse advances from agentic systems to interpretable models, with a special spotlight on the GENS model by Jojic and colleagues as our paper of the day. Join us as we uncover how these cutting-edge studies are shaping real-world AI. Did you know that today's artificial intelligence agents can diagnose electric vehicle battery faults using principles from chemistry, and then explain their reasoning in everyday language? Virtual assistants are no longer limited to simple tasks. They now optimize energy consumption and collaborate across global networks, actively accelerating scientific discovery. Imagine agents functioning as true partners, not just tools. The AI landscape is evolving with unprecedented speed, transforming the scope of what is possible. Artificial intelligence research is fundamentally reshaping science, industry, and daily life. The 29 new papers featured today reveal breakthroughs that are not only technologically advanced, but also deeply relevant to current real-world challenges. This episode will explore not just what is new, but why these innovations matter. By unpacking both the motivations and underlying trends, we aim to offer insights into how AI development blends conceptual innovation with tangible impact across diverse sectors. Think of artificial intelligence as a rapidly expanding city, where each research paper adds a new building to the skyline. Just as city planners must integrate new infrastructure with established roads and parks, AI researchers harmonize logic, data, and human insight to build systems that learn, reason, and adapt. The core objective of computer science artificial intelligence is to create systems capable of evolving alongside their environments, much like integrating old roads with new skyscrapers in a growing metropolis. The first major theme is agentic artificial intelligence, or AI as a digital explorer. Agentic AI systems function as autonomous entities that perceive their environment, reason about the information they gather, and take action accordingly. For example, He and colleagues have developed a smart building energy management agent that learns from user interactions, optimizes resource use, and adapts over time. These agents act as digital navigators, independently charting new territories using sensing and decision-making capabilities. Explainability and interpretability stand out as essential qualities in modern AI systems. It is no longer sufficient for AI to simply generate correct outcomes. Systems must also justify their decisions in clear, accessible terms. BatteryAgent by Joe and collaborators exemplifies this trend, diagnosing battery faults by integrating chemical knowledge with advanced reasoning. Similarly, CogRec combines symbolic logic and data-driven learning, offering recommendations that are both accurate and transparent. The shift is from opaque, black box systems to AI that functions as a knowledgeable, trustworthy teacher, with explainability as a core technical goal. A third prominent theme is the rise of multi-agent and collaborative artificial intelligence. AI is evolving from isolated, single-agent systems to teams capable of coordinated action and complex collaboration. Dong Chu and colleagues present frameworks where language model agents collectively tackle tasks such as collaborative writing and coding. In these multi-agent systems, agents debate, coordinate, and solve problems together, much like a newsroom where reporters, editors, and fact-checkers bring distinct expertise to the table. Multi-agent systems thus exemplify AI working in teams, enhancing both capability and reliability. Recent research yields several key findings that are transforming the field. Hu and colleagues introduce ST-Agent, demonstrating that agents can now generalize knowledge and skills across different domains. The GENS model by Jojic and team reveals that hybrid models integrating statistical and language-based methods outperform language models alone. Correa and collaborators show that iterative deployment enhances both planning capacity and safety in AI systems. BatteryAgent's combination of physical domain knowledge and advanced reasoning sets a new bar for reliability, while Lu's MCP Agent Bench presents a robust, open-source standard for evaluating the tool usabilities of language model agents. Today's featured paper is GENS by Jojic and colleagues, which addresses fundamental limitations of large language models in predictive tasks. GENS integrates language models with traditional statistical approaches to uncover features that are both interpretable and specific to the dataset at hand. This hybrid system boosts both accuracy and explainability, embodying the idea that each error is a clue, much like a detective story, guiding the model toward deeper, more nuanced understanding. GENS operates through a novel cycle of feature discovery. The process begins with a statistical model making predictions and identifying its own mistakes as clues to missing information. A frozen language model is then prompted to suggest meaningful semantic features, which are treated as hidden variables and classified accordingly. The generalized expectation maximization algorithm guides this iterative process, allowing the statistical model to refine its predictions using these new features. The end result is a model that not only predicts accurately, but also explains the rationale behind its decisions. The significance of GENS lies in both its impact and the motivations behind its creation. GENS achieves a median error of only 12% in house price prediction, outperforming large language models that rely solely on broad domain knowledge. In movie recommendation tasks, GENS attains high accuracy using only semantic descriptions, discovering subtle, local patterns that generic models tend to miss. The research team's goal was to enable AI to think like a local, rather than rely exclusively on generalized information. This approach paves the way for more trustworthy AI in sensitive domains such as finance, healthcare, and policy. Looking forward, the future of artificial intelligence resembles a thriving forest ecosystem, diverse, resilient, and adaptive. It is anticipated that symbolic and statistical models will become deeply intertwined, with robust protocols facilitating scalable and standardized progress. Continuous learning and feedback loops will become essential, ensuring that AI systems can adapt to new challenges and environments. The outlook is optimistic. AI is a resilient and supportive ecosystem, providing broad societal benefits. In summary, the field of artificial intelligence is blending innovation with transparency and robustness. Pioneering research by Zhou, Chu, and others is leading the way toward interpretable, agentic, and collaborative AI systems. The future will be shaped by ongoing engagement from the wider community. Listeners are encouraged to explore the research, ask questions, and actively contribute to building the evolving city of AI. The synthesis presented in this episode was developed using GPT 4.1 by OpenAI for content structuring and summarization. Text-to-speech synthesis was performed using Google's advanced tools, while visuals were generated with Stable Diffusion. All content has been reviewed by human experts to ensure accuracy, though minor oversights may persist. References are provided for verification. This collaboration between AI and human expertise ensures both depth and clarity in our analysis. Don't miss future deep dives. Subscribe now to stay ahead with the latest in AI research and trends. This channel, AI Frontiers, is dedicated to helping you explore the world of artificial intelligence. Thank you for joining us, and see you next time. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.